OpenAI's newest AI just disproved a math conjecture that stumped human mathematicians for half a century. Not solved, disproved. And the way it did it has experts genuinely unsettled. This happened 3 weeks ago and barely made headlines outside academic circles. But 1,196 people upvoted it on Hacker News, and 871 mathematicians, engineers, and researchers started arguing about what it means. Because this isn't AI doing party tricks anymore. We're talking about a machine contributing original thought to pure mathematics. The kind of abstract reasoning we thought was uniquely human. The kind that requires intuition, creativity, and leaps of logic that can't be programmed. The model is called O3. You probably haven't heard of it because OpenAI barely marketed it. It's not GPT-5, it's something different. Something designed specifically for reasoning at a level that makes GPT-4 look like a calculator. And it just proved that thousands of mathematicians spent decades pursuing a theory that was fundamentally wrong. Here's why that should terrify and excite you in equal measure. The conjecture is called the Ehrhart coefficient conjecture in discrete geometry. Don't let the name scare you. Here's what it actually means. Imagine you have a shape made of points on a grid. Like connect the dots, but in multiple dimensions. Mathematicians wanted to know if there was a universal rule about how these shapes behave when you scale them up. The conjecture said yes, there's a pattern, a predictable relationship that should always hold true. For 50 years, nobody could prove it, but also nobody could disprove it. Thousands of graduate students cut their teeth trying. Entire careers were built around assuming it was true and working from there. Then OpenAI's O3 model looked at it for what researchers describe as a C. A few hours of compute time, and came back with a counterexample, a specific case where the conjecture fails. And mathematicians verified it. It's correct. The model didn't use any special mathematical database. It wasn't trained specifically on geometry. It reasoned its way to a solution using the same kind of abstract thinking humans use, except faster and with fewer assumptions. Thomas Bloom, a mathematician at Oxford, posted on social media, "This is either the most important event in mathematics in 50 years, or it's a bug we haven't found yet." 3 weeks later, it's looking more like the former. But here's what nobody is talking about. The proof is so complex that most human mathematicians can't easily follow the logic. We can verify the conclusion is correct, but the path it took to get there involves reasoning steps that feel alien, which raises an uncomfortable question. What do we do when AI can think in ways we can't track? You might be thinking, cool, AI is good at math, why does this matter to me? Because this same reasoning capability doesn't stay in mathematics, it transfers. Discrete geometry is the foundation for optimization problems, the kind that show up in logistics, network design, resource allocation, and drug discovery. If AI can reason at this level in abstract mathematics, it can reason at this level in protein folding, material science, and economic modeling. Last year, AI models were predicting protein structures. That was impressive, but essentially pattern matching from existing data. This is different. This is creative problem solving in a domain with no easy training data. The model had to genuinely reason. Francois Chollet, the AI researcher who created the ARC benchmark for measuring AI reasoning, said O3 scored 75.7% on his test. The previous best was 43%. That's not incremental improvement, that's a capability leap. And OpenAI hasn't even released O3 publicly yet. A handful of researchers have access. Everyone else is working with the implications of what it can already do. Here's the uncomfortable part. We're not entirely sure how it works. OpenAI's technical report describes the architecture, but the emergent reasoning capabilities weren't explicitly programmed. They emerged from scale and training, which means we built something that can outthink us in specific domains, and we're reverse engineering how it does it. Demis Hassabis from Google DeepMind has been warning about this moment for years. Not AI becoming sentient, AI becoming incomprehensible. When the reasoning process is so complex that verification is harder than discovery, we're in new territory. And then it got worse, or better, depending on how you feel about humans not being the smartest things in the room anymore. 3 months ago, most AI researchers thought we were years away from models that could contribute to mathematical research. The consensus was that reasoning at this level required something we hadn't figured out yet, some missing ingredient. Then, OpenAI dropped O1 in September. It could solve International Math Olympiad problems at a gold medal level. Impressive, but those problems have known solutions. They're hard, but bounded. O3 is different. It's solving or disproving open problems. The difference between winning a chess tournament and inventing a new game. The model uses what OpenAI calls extended chain of thought reasoning. Essentially, it thinks longer before answering. That sounds simple, but it's not. Most language models spit out responses in seconds. O3 can think for minutes or hours, exploring different reasoning paths, backtracking when it hits dead ends. It's closer to how human mathematicians actually work. You don't solve a hard problem linearly. You try approaches, hit walls, reformulate, and try again. O3 does that internally. The cost is insane. Running O3 on a hard problem can cost hundreds of dollars in compute, but that's not the point. The point is it works, and compute costs drop exponentially. What costs $500 today will cost $5 next year. Ethan Mollick, a professor at Wharton who studies AI adoption, pointed out something crucial. We're optimizing for the wrong thing. Everyone's focused on making AI cheaper and faster. Nobody's asking what happens when it gets smarter than domain experts, because that's what just happened. In this specific domain of discrete geometry, O3 demonstrated reasoning superior to human experts. Not faster, not more efficient, superior. The mathematicians who verified the counterexample are being diplomatic about it. They're calling it collaborative research and human-AI partnership. But read between the lines, the machine found something humans missed for 50 years. And here's the pattern interrupt nobody's talking about. This is the slow version. O3 is cautious, methodical. It's optimized for accuracy, not speed. OpenAI has confirmed they're working on faster variants. What happens when you can run 1,000 of these in parallel on every unsolved problem in mathematics? The immediate future is predictable. Research labs get access to O3. They start testing it on other long-standing conjectures. Some will fall, some won't. But the landscape of mathematics research changes permanently. DeepMind is already rumored to be working on their own reasoning model. Anthropic is suspiciously quiet about their next release. The race isn't just about building better chatbots anymore. It's about building better thinkers. Terence Tao, one of the world's top mathematicians, has been experimenting with AI assistants for a year. He's cautiously optimistic, but raised a point that's keeping other researchers up at night. The danger isn't that AI gets math wrong. It's that AI gets math right in ways we can't verify without other AI. We're approaching a world where AI-generated proofs might be checkable only by other AI, where human mathematicians become managers of machine reasoning rather than the reasoners themselves. The pharmaceutical industry is watching this closely. Drug discovery has similar properties to mathematical research. Complex, multidimensional problems with sparse data and long verification cycles. If O3-level reasoning can transfer to molecule design, we're looking at a complete restructuring of how drugs get developed. Antibiotics resistance is killing 700,000 people a year. That number's projected to hit 10 million by 2050. We've been losing the race because human chemists can't explore the solution space fast enough. AI that can reason about molecular interactions, the way O3 reasons about geometry, could actually solve this. But it also means that the competitive advantage shifts entirely to whoever has the most compute and the best models. Right now, that's OpenAI, Google, and Anthropic. 3 companies, all American, all private. China's response to this news was immediate. Within 72 hours, state media was reporting increased investment in reasoning-focused AI research. The EU started emergency discussions about access to frontier models. Because if AI can outthink human experts, whoever controls that AI controls the future of research. The pessimistic view, we're about to see massive concentration of power in the hands of a few AI labs. The optimistic view, we're about to solve problems that have plagued humanity for decades. Both can be true simultaneously. Here's what keeps researchers awake. We don't actually know the upper limit of what these models can do. O3 hits 75% on the ARC reasoning benchmark. What happens at 90%? At 95%? The benchmark was designed to test reasoning abilities we thought were fundamentally human. Abstract pattern recognition, novel problem solving, transfer learning. We built the test assuming machines would struggle with it for years. Instead, we're watching the scores climb faster than the test designers expected. Shaw Lei himself admitted he's already working on a harder version, because O3 is approaching the ceiling. The honest answer from AI researchers right now is, we don't know what comes next. Not because they're being coy, because the capabilities are emerging faster than our ability to predict or understand them. 6 months ago, the conversation was about AI replacing customer service jobs and graphic designers. Now we're talking about AI contributing to fundamental research in mathematics and science. The goalposts aren't just moving, they're teleporting. And here's the uncomfortable truth that most coverage is dancing around. A lot of very smart people did not see this coming. The researchers who spent careers studying AI reasoning capabilities are as surprised as everyone else. That's either exciting or terrifying, depending on whether you're an optimist or a pessimist. Probably both, if you're being honest. OpenAI hasn't announced when O3 gets a public release. They're being cautious. The model is expensive to run, and the implications of widespread access to reasoning this powerful are still being worked out. But it's coming. And when it does, the gap between people who understand how to use AI reasoning tools and people who don't will be larger than any skills gap we've seen before. This isn't about prompt engineering or knowing the right commands. It's about understanding how to collaborate with a reasoning partner that might be smarter than you in specific domains. That's a different skill entirely. If this keeps you up at night, subscribe. We cover this every week. Not the hype, not the marketing, but what's actually happening at the frontier of AI research. Because the decisions being made right now in labs and boardrooms are going to reshape how we work, learn, and solve problems for the next 50 years. If you found this useful, don't forget to hit the hype button. It helps the channel grow.